in this video, we're going to be doing a question on the titration. We're going to be titrating a strong acid and a strong base, and we're going to be doing the stepwise titration where what happens to the pH after adding a particular amount of base in a given amount of acid. So the question is, I have 50 milliliters of solution of 0.5 molar HCl, and that is going to be titrated with 0.25 molar LiOH, and you're going to have to calculate the pH after some of those points, like when there's no base added, you have some of the base added, you got some more base added, and so on. So let's look at those step by step. Before you do anything, you want to make sure you're able to write down the equation so that you know the relation between the acid and base in terms of the stoichiometry. So I got HCl. The HCl is going to be reacted with LiOH, and obviously your acid-base reaction is always going to make water as one of your products, and then your other product is going to be the salt, which in this case is going to be the LiCl. And it seems like this reaction is already balanced, so we have a 1-to-1 mole ratio of your acid and base in there. What's also important here to be able to know how many moles of the acid you're really dealing with, and we don't know the moles of base yet until we'll know when you will add starting some of the base, because you have to figure out how much of the base, how much of the acid is being neutralized by adding the base. So I have 50 milliliters of HCl solution, so that's going to be 0.05 liters of HCl. And then if I want to go ahead and figure out the moles there, I would do 0.5 moles of HCl per liters. So liters cancels out, and then that's going to give you 0.025 moles of HCl. So that's one important information you want to make sure you know. So when there is no LiOH added, the only thing you have is the HCl. So you know HCl is going to be a strong electrolyte where it's going to dissociate into ions completely as an H plus and Cl minus, and make sure you know the other way of writing that equation as well. So you may see in the books this equation written as HCl plus water liquid. So HCl is going to be an aqueous, and that's going to be protonating the water completely as an H3O plus aqueous and Cl minus. So both of those ways are okay. You may see sometimes books writing the first way and sometimes books writing the second way. But since we know it's going to dissociate completely, the concentration of the H plus at the end of the day, which is going to be obviously the same as H3O plus, is going to be whatever concentration of HCl you're starting out with, because it's in a strong electrolyte that dissociates completely into ions, so zero point 0.5 molar. And once you know the H plus concentration or the H3O plus concentration, you can easily calculate the pH. So the pH here is going to be negative log of the H plus or the H3O plus, which is going to be 0.5. So whatever that's going to be. So that comes out to be 0.3 as your pH initially. Now, as you move along, now you're going to be adding 50 milliliters of LiOH. Since you're doing in a strong acid, strong base, first you need to figure out how much of the acid is being neutralized by this 50 milliliters of LiOH, and then focus on whatever is left over, whether it's the base left over or your acid left over. So to do that, figure out your moles of LiOH here. So I know I'm doing 0.25 molar LiOH. So I'm going to be starting out with 50. Let me change the color there. So it's 0.05 liters of LiOH, and then we have 0.25 moles of LiOH time divided by liters. So when I do this math, it's going to be 0.5, or rather 0.05 times 0.25. So it's going to be 0.0125 moles of LiOH there. And then when I'm looking at the equation, I know it's a 1-to-1 mole ratio. And if you want to go ahead and figure out, write down the ICE table or ICF table, that's completely okay as well. But if you can just do it in your mind, that's fine as well. So we can clearly see the HCl moles initially was 0.0025, so that we have calculated earlier. The LiOH moles is going to be 0.0125, so don't worry about water. And then LiCl, you don't really have it in the beginning, but you don't really have to worry about how much you make anyway, since you're doing in a strong acid. So this is rather going to be called an ICF table, since you're doing this in terms of moles. So your limiting reactant here is still going to be the LiOH, so I'll lose all of that, and in doing so, I will neutralize that many moles of your acid. So you don't have any base left. So how much HCl are you going to have left over here? Well, you just subtract 0.025 minus 0.0125, and that's still going to be 0.0125 moles. So now I know the moles of HCl that's going to be left over would be 0.0125. And then what's going to be the concentration then? Well, remember, whenever you're trying to find the pH, you must have the concentration of HCl or the H plus. So in this case, the HCl concentration, or that's going to be the same as H plus because it's a strong electrolyte, it's going to be 0.0125 moles divided by whatever volume going to be. So what's the volume now? Well, remember, you started out with 50 milliliters of HCl solution, but then you now added 50 milliliters of LiOH. So your total volume is going to be 100 milliliters. So don't forget to add the volume of the base that you're adding. So 100 milliliters is going to be 0.1 liters. So that's just going to be, seems like 0.125 molar. So now I know the H plus concentration. I can easily calculate the pH by doing negative log of 0.125. So let's see what that comes out to be. So it's going to be 0.90. It's always going to be a good idea to have two decimal places when you're doing these pH calculations. Okay, so you can clearly see originally your pH was 0.3, and then now you added a little bit of base. So what should happen to the pH? If you're adding the base, your pH should go up. So that's exactly what's happening now. The pH went up to 0.90, and that's what we're going to have to keep doing until we do all of these sets here. The next question, the question or the part is you adding 100 milliliters of LiOH. So before I do anything, I want to go ahead and figure out how many moles that's going to be. So zero point 0.1 liters of LiOH, and then I know we have been dealing with 0.25 molar. So 0.25 moles over liters, so it's going to be 0.025 moles of LiOH. And then I can go ahead and do the ICF table again if you want, but then always kind of look at these numbers in your mind as well. So I'm just going to copy this down here. I'll put that down here. I'm going to change the color as well. Okay, so I'll erase a part of it first. So I know now LiOH moles are going to be 0.025, and now I have an equal mole. So another way of saying moles of acid equals the moles of base. So I lose both of those. There's no limiting reactant. Both of those get consumed right away. And when you have the moles, I'll say moles of H plus equals moles of OH minus, that means you are going to be at equivalence point. And whenever you're titrating a strong acid and a strong base at equivalence point, you're only going to have water left, and there's not going to be any base or acid left over. So your pH is going to be 7. So you don't really have to do any calculations, but just knowing that pH is going to be now 7 since it's a strong acid and strong base. Now let's look at this last one here. What happens when you add 110 milliliters of LiOH? Once you have passed the equivalence point, what matters now is how much excessive or how much extra base you have added. So I know I needed 100 milliliters to reach the equivalence point. That means I'm going to have 10 milliliters of LiOH extra in there. So I'm going to work on that for a bit. So figure out how many moles of LiOH you're going to have. So I would go ahead and do 0.010 liters of LiOH, because remember to convert the milliliters to liters. And then I'm starting out with 0.25 moles divided by liters. That's the concentration of your LiOH that we are given in the beginning. So that's going to be your 0.0025 moles of LiOH. Now you also want to calculate the concentration here, because you're not going to be able to calculate the pH or pOH just from the moles. You need the concentration. So I'll do the concentration of LiOH is going to be 0.0025 moles of LiOH divided by the volume. What's going to be the volume? Well, remember you started out with 50 milliliters of HCl in the beginning, and now you have added another 110 milliliters. So your total volume here, I'll write that down on the top there, is going to be 50 milliliters of HCl and 110 milliliters of LiOH. That's 160 milliliters. So that's a common mistake students mistake. They don't count the total volume at some points. So it's going to be 0.160 liters. So let's see what that going to be. So it's 0.0025 divided by 0.160. So it's going to be 0.0156 molar. Now I'm dealing with an LiOH, and you know it's going to be a strong electrolyte or strong base here. So this LiOH is going to be completely dissociated into Li plus and the OH minus. So that means the concentration of your OH minus here is going to be 0.0156 molar. So I'm not going to be able to get the pH straight, but rather go ahead and calculate the pOH first. So the pOH is going to be negative log of this 0.0156. Now let's see what that comes out to be. So negative log of this 0.0156 is going to be 1.81, and then I can go back and calculate the pH by subtracting it from 14. So 14 minus 1.81. So let's see what that comes out to be. It's going to be 12.19. So that's going to be the final pH after adding 110 milliliters of your LiOH, which makes sense because now you pass the equivalence point. Now you're going to have an extra base in there. So that extra strong base is going to give you a basic pH, which is going to be closer to 14. And that's exactly what we get. We get 12.19 as your. So this is how you're going to be titrating a strong acid with a strong base, and mostly you're going to be looking at, be able to figure out how much you have neutralized, how much you have left over, convert it back to the concentration, and then kind of go from there in terms of finding the pH. If you have any questions on this question, feel free to leave any comments in the section below.